Hello students, in this video lecture we are going to discuss what do you mean by dual of a PO set or a dual of a partially ordered set. So let me define what do you mean by dual of a PO set. So let P be a PO set or a partially ordered set. Then the dual of the PO set P, which is denoted by P dual, is another set whose elements are same as that of P. This is one thing. And secondly, the ordered relations or the relation less than equal to in P dual is defined as follows. Now, if you have x and y are two elements of P dual, of course, if x and y are elements of P dual, then x and y are also elements of P because we just said that their elements are same. So, if x and y are elements of P dual, if x and y belong to P dual, then we say that x is related to y in P dual if and only if y is related to x in P. This is the way how we define the ordered relation in P dual, that an element x will be related to y in P dual if and only if you have the element y is related to x in P, which means that if and only if means that this relation is implies and is implied by that if x and y belonging to P dual are such that x is related to y in P dual, then this would imply that y is related to x in P. And the converse is also true, that if y is related to x in P, then x will be related to y in P dual. Now, what is the meaning of this line? There is an observation that we have from here. The observation that we have from here is the first observation. There are actually many observations that we have from here. So the first observation that we have from here is that if let us suppose that x and y are two elements belonging to P dual, and if x and y are two elements belonging to P dual, then of course x and y belong to P also because their elements are same. So if x and y are elements belonging to P dual, x and y of course belong to P, and let us suppose that x is related to y in P. Suppose x is related to y in P. Now, if x is related to y in P, then this means the opposite holds in P dual, which means y would be related to x in P dual by definition of P dual. Now, what do you mean by saying that x is related to y in P? X is related to y in P means that when you draw the hash diagram of or the diagram, simply the diagram of the PO set P, then because x is on the left and y is on the right, so x will be at the bottom and y will be at the top. Or there may be other elements in between about which we are not sure. We know just about the relation between x and y, that because x is less than equal to y, x will be at the bottom and x will be below y, and y will be above x. This is the relation. Now, because the opposite holds in P dual, here x is related to y in P, but the relation which holds in P dual is the opposite, which means y is related to x. This means that what will happen over here, because y is on the left and x is on the right. So when you draw the diagram of P dual, the hash diagram of P dual, we are going to prove later on that this P dual itself is a PO set. So because it is itself a PO set, you can draw its hash diagram. So when you draw the hash diagram or simply the diagram of P dual, then because y is on the left, x is on the right, so y will be below x, like this. There may be elements in between, but in the hash diagram, y will be below x and x will be above y, which means that if you have a structure like this in P, x down, y up, then the structure is opposite in P dual, which means that y will be down, x will be up. So this simply means that if you want to draw the diagram of the PO set P, we have not yet proved that the dual of P is a PO set. We are going to prove it in next. But then if you draw the diagram of P dual, if you want to draw the diagram of P dual using the diagram of P, the only thing that you have to do is you have to turn the diagram of P upside down, which means that you have to just you have to imagine as if you are holding this element over here and you are putting it up. So x goes up, y comes down if you just hold it, and if you turn it upside down, so x goes up, y comes down, which means that if the, let's say the diagram of P is like this, like this. This is the diagram, and let's say this is the element x, this is the element y, this is the element z. So this is the diagram of P. And now if you want to draw the diagram of the PO set P dual, you just have to hold these two elements and you have to lift them and you have to turn the diagram upside down, and this is the diagram that you will have for the PO set P dual, which means x at the bottom and y and z above x. So this is what we have. So this is one observation that we get from here. Now coming to the second observation, The second observation is that for every statement S that you have in P, there is a dual statement which we denote by S dual in P dual. If there is a statement S about ordered relations and all, which you have in P, there will be a dual statement which we denote by S dual, which exists in P dual. Corresponding to S, there will be a corresponding statement S dual that we will have in the PO set P dual, where how will S dual be obtained? S dual will be obtained from S by replacing every occurrence of less than equal to sign or greater than equal to sign by this less than equal to will be replaced by greater than equal to, and this greater than equal to will be replaced by less than equal to. So everywhere where less than equal to or greater than equal to is coming in the statement S, you have to correspondingly replace less than equal to by greater than equal to and greater than equal to by less than equal to, and we'll get the corresponding dual statement S dual in P dual. For example, let's say there is a statement S, and let's say the statement is X is related to Y is related to Z, or X is less than equal to Y is less than equal to Z, and let's say this is greater than equal to, let's say, another element, let's say W is related to Z. Suppose there is an expression like this which holds in P. Let's say these are all elements of the PO set P. Then the dual statement of this statement would be S dual. This is the dual statement, and everywhere where less than equal to is coming, you have to replace it by greater than equal to, and greater than equal to has to be replaced by less than equal to, which means the dual statement is going to be X is greater than equal to Y is greater than equal to Z is less than equal to W. This is the corresponding dual statement, and this is true in P dual. This statement holds or this statement is true in P, and this statement holds or it is true in P dual. So this is the second observation that we have. Now coming to the third observation. Now if there is a statement S about ordered sets, which is true in all the ordered sets, then the dual statement of S, which is S dual, this will also be true in all the ordered sets or all the partially ordered sets or all the PO sets. So let me repeat, if there is a statement S which gives you some expression or some result related to ordered sets or we can say the partially ordered set, and suppose this statement S is true in all the PO sets, then the corresponding dual statement which we have denoted by S dual, that will also be true in all the partially ordered sets, and this particular fact which I have just told you, this is called the duality principle. This principle is called the duality principle. So what is duality principle? Duality principle is that if there is a statement S which is true for all the PO sets, then its corresponding dual statement S dual is also true in all the PO sets. These are the three observations that we have about the dual of a PO set. The hash diagram of the dual PO set can be drawn easily using the hash diagram of P. This was the first observation. The second observation was that corresponding to every statement S that you have in the PO set P, you have a dual statement S dual in the dual PO set. And the third observation is the duality principle, which I have just discussed. It yet remains to be proved that the dual P dual of a PO set P is itself a PO set. This, of course, I'll take in my next video.